I started off working on weird Linux managed routers. We installed a bunch of things in the desert for a gold mine once upon a time. I remember driving across sand dunes and having to do a forward driving course. That was fun. And then I worked for Google for about 10 years, a bit less, 9 years. And that was very interesting. And then Rackspace, working on OpenStack for a couple of years. And then when I came out of Google, I kind of missed. I went in right as Amazon and the whole Amazon AWS EC2 thing started. And I kind of missed that whole thing. I disappeared into the Google vacuum and then came out and sort of looked around and went, oh, I want to run some software. How do I do that? Oh, well, I'm used to this certain way of running things from inside Google, containers, sort of an active management thing, and didn't really find that, which surprised me a bit. And so Kubernetes was sort of coming out around then as well, so I got involved in Kubernetes quite early on, both as a user trying to run OpenStack bits on it, which was a bit of a failed experiment at that time. It was a bit too early for both projects. But then I ended up writing the OpenStack cloud provider plugin for Kubernetes. And I'm still one of the main maintainers for that. So that was interesting. And then I am now working for Bitnami on Kubernetes things full-time as my main job. So this talk is only about a very small amount of that, but I'm very happy to talk about any of that later on today or tomorrow if you want. All right. So as I said today, I'm just going to be talking a small amount about something that we're working on called Cubelets, which is a functions as a service or serverless framework for Kubernetes. But most of my talk's not really about that. It's really going to be about the background and why we think this is interesting. Why now? Why this project? Why Kubernetes generally? I'm kind of building on some of what Brendan said this morning, but I'm kind of starting further back and then coming into something narrower at the end. So yeah, why? I think it's easy, as technical people, it's easy to talk about details. We talk about details a lot. You can go to READMEs, they're full of details and specific things. We give talks about specific architecture. I feel we don't often enough kind of sit back and reflect and say, why are we doing this? Why is this the right thing to do? How do we get here? So I like to use conference talks to talk about that because it doesn't normally get discussed. We don't normally put words around these ideas. So, all right, you write some software. It relies on a lot of other things. Software is like an onion, as I say. And over time, each of these sorts of levels gets experimented with. We try out different ideas, and then we sort of consolidate down to a small number of choices with some sort of niche uses that are still left. And then it's certainly been clear over my career, and I imagine the rest of you have seen this too, that we're sort of slowly going up this stack, right? We're slowly going through each of these pieces, and they're sort of experimented with. We have a few ideas, we consolidate down to 1 or 2 or 3, some small number of ideas, within a few sort of niche areas left. And then we're slowly going up the stack. I certainly remember a long time ago when we had more than one CPU architecture. Nowadays we really only do for phones, but servers, pretty much all x86 64. I certainly remember when there was other flavors of Unix around. We don't have that anymore, right? So a lot of this consolidation goes on. Here's kind of what, if there's business people in the room, I apologize. This is just what the vision is in my head. This is how I think of this. I think of projects as starting off at this sort of crazy experimental end. They're very novel, they're very new, they're a long way out there compared to what everyone else is doing. And the risk in those projects is quite high, the uncertainty. Even if they work, you don't know whether there's going to be a big self-sustaining community around them, in 5 years' time. And then as they get used a bit more, get adopted a bit more, they sort of go through this middle period where they very quickly, I feel, drop from the crazy experiments down to what is quite normal sort of software. And then when something is widely used and deployed and it's been used for years, there's very low risk. It's everyone uses Linux kernels now. There's not a whole lot of risk in going to your management chain and saying, we'd like to run a Linux server in our data center. That's a very, very safe proposition right now. So there's kind of these three phases, right? There's the crazy experiment phase, there's the kind of maturation bit where everything's sort of consolidating and quickly coming down, and then you've got the commoditization where it's just so normal, no one even talks about it anymore. Or as I'm sort of, and businesses usually, I find, want to be around that maturation bit. They want to be there where it's a little bit of risk. It's not a commodity area yet. There's room for putting your project out there versus some competitor's project. But it's a year, 2 years worth of risk that you can survive a bit of venture capital, a bit of investment, R&D investment. And then certainly open source completely has dominated the commodity end of the spectrum. All the free software stuff, the just run it and use it, it's zero cost, zero licensing. There's no room left down that end for businesses to differentiate, to say, why should you buy my offering versus a competitor's offering? Because they're all the same at that end. So there's no room there. Or as I'm going to talk about it, I think during this talk, there's the boring phase where you just don't talk about it anymore. It's just assumed everyone has it. There's the interesting phase where there's ideas, there's viable alternatives. You go to conferences to talk about them. You're all here because kind of Docker and Kubernetes and Swarm and these sorts of things are in the interesting phase. That's why you're here. You go to conferences about your framework choices, these sorts of things. And then there's the crazy end, or the niche end, to be nicer. There's legitimate reasons why you want to be out there, but they're a particular market, they're a smaller market, they're specialized, or they're crazy projects. They're really sort of pie in the sky. These may or may not work. Very experimental. And so open source, free software, I find, comes in at the two ends and in the middle, but then the businesses are also obviously present in the middle there where there's that value to be made. And the thing that I think I've come to realize is that the width of that middle section kind of stays the same. Doesn't really matter what the technology is, doesn't matter where we are in the kind of decades that have gone past. You've only got a certain budget, a certain appetite. Any business, any project, any free software project can only really devote a couple of years of a smallish team of people, like a year worth of maybe less than 10 people. That's sort of about the size. And even in a big company, it's not a whole lot bigger. So you've only got this certain amount of effort that you can explore off into the future on what you're hoping to become a commodity, boring, safe project. So I find that middle section sort of stays fixed in width, I find, which I find interesting. Anyway, so coming back to my software stack, here's sort of the server-side software stack, and this is where I start getting a bit opinionated here. It's taken decades, but I feel, when I started, certainly electricity and cooling and physical enclosures, they were already commodity. You already had 19-inch racks was everything. 240 volts or something similar was everything for electricity. And then certainly I've lived through the consolidation of server CPUs going onto Intel and operating systems collapsing onto Linux. I feel we're still talking a little bit about software distributions, but they're kind of becoming boring. Not that many people go to a Red Hat conference or a Linux conference or a Debian conference or something anymore. Probably when Ubuntu came around, that's when we were still talking about that. That was a decade ago. People are still going to conferences about languages and frameworks, and that's still active areas of conversation. So I feel that's still the interesting section. And then the top bit, of course, will always be there, because there's always some problem that you're solving, or else you're not even talking about this sort of problem. So there's always something you've got at the top that's yours. Yeah, and so you can see over the last sort of decade or a couple of decades how that's moved up the stack. And obviously you can't settle on some de facto standard until the below layers have settled on some similar standard. You can't build your next layer until you've already agreed on what the lower layers look like. So it kind of has to happen in order to some extent. All right, now the interesting thing that I find when I look at Kubernetes and Docker and why I find these technologies interesting is that I feel they've really brought that up. And they've brought up not the top part. They don't allow you to do new things that you couldn't do before. is that they've brought up the bottom end, the low watermark of interesting. They've raised the level of boring. Right? Now, all of a sudden, we're no longer talking about languages as much or frameworks as much. And we're certainly not talking about software distributions, Linux distributions anymore. Because you know what? You can just roll out a new Docker container and it embeds them all in there, and it's not that controversial anymore because you can mix this, Python, whatever software stack running on a Red Hat distribution, and you can run it alongside a Debian distribution with a totally different stack or a mismatched version of Python with a different conflicting set of requirements, and it's okay. And Docker's really made that possible, and then Kubernetes has really just made that easy to use, normal to use. So kind of the point of my talk here is it's not about making new things possible, it's about bringing up the bottom level and making new things boring. We're making new things, it's not so much that some people can do these things, it's now everyone can do these things. We're assuming this level of functionality now exists everywhere. And this is actually exciting. It's a big new thing, right? I can now go to someone and I can hand them some Docker image and I can expect them to be able to run that and understand how to use that. And very soon, if not now, I can do the same with Kubernetes. I can go to someone and expect them to be okay with me saying, here's a Kubernetes definition of my service. You know how to run that. You know how to take advantage of that. And that's really cool. And I think I can talk about this not being Google anymore. I feel like Kubernetes has cheated a little bit on this curve. If I go back to this curve here, there's a lot of Kubernetes feels new to a lot of people, and I understand because it is. It's only 2-3 years old as a public project. But for someone coming from Google, and you've seen a lot of ex-Google names or current Google names around in the talks, this is old technology. When I started in Google in 2005, this is what I was using every day, already back then, in its early forms. And so this, from that point of view, is already a 10-year-old technology. It's already been well experimented on. It's gone through those several evolutions. We know sort of what things are required to describe jobs. We know how to run a fairly mixed workload with it. We know how to configure it. We know how to debug it. We know the sorts of features that are required in order to do those sorts of things. Now, it's not quite that simple, of course, but it's sort of cheated. It's come out as both a sort of experienced project, but at the same time has come out as free software. So it's leapfrogged straight into that kind of mature end and into the commodity end. You don't have competing people selling something that's Kubernetes compatible, right? There's only one, and it's free, and you're done. So it's still got some adoption, like people are still new to it, they still have to take it up, but I fully expect Kubernetes to leap very quickly into this boring category because of these things. So what we've achieved, which is a big deal, is we've shifted the focus of pretty much our entire industry. We've been working for decades to get to the point of being able to say to people, you know how you wanted to run a program, you know how your problem you actually came to me with was, I have this problem, I want to solve it, it involves some software. Oh, you mean I've got to go and buy a server, I've got to plug it in, I've got to find someone to replace the hard disks at 3 a.m, oh, I've got to install manage the kernel and then distribute upgrades and what happens when it fails, and then I've got, we've solved all those problems. Not that everyone's doing it yet, not that it's easy, but we now have solutions for pretty much that entire stack, all the way up to the bit where you're running your software. And this is a big deal. We should feel really proud about this. It took decades, and we're there. So what we're really doing, what we talk about Kubernetes, is it's really shifting from the hardware and the orchestration. They're all automatic, they're all assumed, they're all boring. And we've shifted to the application level. We're now talking about what program am I going to run? What version should it be? What command line arguments should it have? How is it going to talk to other programs? Right? It's all the way up to application level. And again, this is a big deal. So if I could make a pithy little line here, boring is now how we do things. Interesting, in that interesting period, is now what we want to do. Okay, we're not talking about should I run Ansible and Puppet and what versions of Debian packages should I install. We're done with that. Okay, and this is really cool. So you can see from the talks we've had today and the talks we'll have tomorrow, there's a lot of focus on what do we want to run? How do we describe our workloads? How do we talk about that? We're all working now at the what level, the application level. And this is cool. So let's talk about what. This has got a nice creaky floor here. It's good. There's a lot of projects going on here, and I'm not even going to attempt to list some of them because there's so many and they're so broad and so interesting. Just at Bitnami, we're a fairly small company, but we're just in our company, we're working on a whole lot of areas. The Helm charts you saw this morning, Monocular, Cubelets.com, that's written by some of my colleagues and maintained by them. We contribute a lot to the Helm charts. The WordPress one, again, you saw this morning. The reason the password was Bitnami is because it's our container that's underneath that. Kubeconfig is a project I've been working on, and you'll hear more about that in the next couple of days from some of our partners in that project. Someone asked earlier on about Docker Compose and how you get from Docker Compose to Kubernetes. Compose with a K is a tool to help you do that. It's not perfect because the two don't match exactly, but it does a pretty good job of getting a Docker Compose described job and running it as a Kubernetes job. Stacksmith is a tool to help you update and maintain your images and get security updates and rebuild your image on top of the new versions of the base package. And then today I'm going to be talking about a little bit about our functions as a service project that we're experimenting with. But the main thing I wanted to focus with here is that just in our small company, there's lots of projects, and they're all about how do I describe my workload? How do I talk about the applications? How do I talk about what it is I want to run? All right, so a lot of code, just generally, is glue code. It's simple little shell scripts, or simple little pipelines, and people scoff at them. People don't talk about them. You don't go to a conference and talk about your shell pipelines. I wish you did, that'd be cool. But the fact is, this is necessary. Companies, no Unix machine for decades has actually booted up without running a shell script at some point. And so people joke about this not being a real programming language, and yet every machine out there relies on that working in order to start. And so the same problems exist in the new distributed microservices container world. We still have little bits of glue. I still have that 10 lines of code where I just need to get that input and turn it into the output. I have to get that thing and make sure it matches my particular business requirements, and then return true or false. Like all those little bits of code still have to be somewhere. A lot of those happen with webhooks. It's kind of the equivalent of a shell pipeline. Something happens, you send an HTTP post or GET or something to somewhere else, and you get a response back. So they act like web servers, but the logic behind them is usually this much code. And very quickly, you end up with diminishing returns. Even with, GitHub's pretty nice, Docker Hub's pretty nice. They work together very well. But I get frustrated every time I have to go and, I have 10 lines of code. I have to go and create a Docker file to put it in. I have to put that in the Git repo. And then I have to go to Docker Hub, and I have to plug Docker Hub up to GitHub so that it can pull from there and auto-build the images for me. And then I have to go to my Kubernetes config and consume that Docker version. It's all pretty straightforward, but for 10 lines of actual content, there's rapidly diminishing returns on all that extra work. If I've got to click 10 times to get my 10 lines of code out there, it's kind of break even at that point. So here's an example of Cubelets, and I picked a not hello world example. There's lots of, just return the string you put in. This is a real example here. It generates a thumbnail. So when you upload an image to min.io. It's an object store. It's a bit like S3. It's simpler. You can run it yourself. You upload a file to there, and you can see it is the file extension, this is written in Python. It just gets the file name that was passed up. If the extension is .jpeg, then it carries on, and it says, all right, if this is this event, the object was created, then create a temporary file, fetch the contents of that file, use a Python library, just a standard Python library there, to rescale the image to 120 by 120 pixels, and then at the bottom there, re-upload it into a new file with a new thumbnail. Very simple. And yet this is a real project. Imagine doing this a few years ago. That would have taken actual work There would have been an actual team there. There would have been, some thought. This is instead, 20 lines or something of Python, and it's throwaway simple. And there's lots of examples like this. Just a couple of weeks ago, I wanted to hook up our Jenkins at work with our new GitHub repo, and I wanted to get the GitHub webhook to hit Jenkins to trigger the automated tests to run. Simple, but for our security policy, quite a sensible policy, I didn't want to expose Jenkins to the outside world. So I write a little webhook that is really just accepting the GitHub webhook coming in and then bouncing it through our kind of Kubernetes DMZ setup to my internal Jenkins and passing on the webhook there. Very, very simple, 10 lines of code, not worth setting up Docker Hub for, not worth setting up all the other things for. So yeah, just to finish that off, you run Cubelets, you tell it the name you want to create. The fact that this particular one is triggered by a Kafka pub sub topic. You can also do HTTP triggers, and you can imagine others in the future. This one uses the Python 2.7 runtime. We support Node.js and Ruby, but again, more if anyone wants any others. The handler tells you what function to invoke within the Python world. And then you're getting the code from that file, and it has a few dependencies because I was using those libraries in Python there. And that's it, done. There is nothing else to do. I'm not even going to type it in and show you because it's boring. You know it's going to work. It's just fine, right? It's boring. This is a bit of a gimmick, but it's quite nice as well. We have a web UI that's being written around it, and it just type the code and it creates a function for you. So it's just a wrapper around that, the equivalent of that command line there, but now in a web form. So you can type out your 10 lines. You can give it to someone who doesn't know the rest of Kubernetes. They just know how to write their 10 lines they need to write in whatever language. They can press run function, and away it goes. So how does it work? The user creates their resource. Again, Cubelets is trying to be very, very simple. So you create a third-party resource. I think Brendan talked about them this morning. They're a fairly newish feature in Kubernetes, where instead of just the regular Kubernetes objects, your service deployment, config map, you can create a third-party one. You can say, I want to invent a new one. And we invented a new one called function. Or it's got a domain name in front of it, but that's it. And so you can use the regular kubectl client or the custom kubeless client, and it creates a third-party resource, which I'll show you on the next slide. And then we have a little controller that runs in the cluster, a lot like Helm, which had Tiller. We have a kubeless controller that runs in the cluster. It notices a new one of those was created. It goes, aha. And then it goes and creates a config map, a deployment, and if it's an HTTP triggered function, it creates a service. Very simple, very normal. It's what you would do normally by hand, except it's automatic. The code you gave goes into the config map, which then means when the deployment starts up, it mounts the config map, so now it has the code available. And in the deployment, it has the runtime running. It turns into a container that's going to start. And so the Python 2.7 runtime container knows how to read that file from the config map, knows how to start it up, has the standard boring environment around it, and it knows how to serve requests. Very simple. Tomorrow there'll be a talk from Vishal about some other implementations of functions as a service on Kubernetes. And they're great. There's a lot more features than some of the others. Cubelets is trying to be very simple. And you can see here, very simple. Yeah, so on the right there, there's that third-party resource. If you wanted to create it by hand, that's what it looks like. Standard Kubernetes definition. It's got the function in there. It's got the requirements.txt equivalent in there somewhere. It says the runtime, the topic you want to listen on to, and the fact, in this case, it's a pub sub-driven event rather than an HTTP-driven function. In the runtime, you get Prometheus metrics, you get health checking, you get all that sort of stuff from the runtime for free. We export metrics about how long your function takes to run, how many errors there are, how many function requests you're getting per second. those sorts of generic things. And then because it's building on Kubelets, we get a whole lot of things from Kubelets for free. We get auto-scaling, we get restarting, we get health checking, upgrades, the full benefit of Kubernetes. And partly why we're trying to be very simple with the design of Kubelets is we want to benefit from that for free. So there's been a discussion happening about we create one pod per function, which if you look at some of the AWS sort of Lambda offerings, that's a bit strange because AWS, it's all about if you're not calling your function, there is no cost. Whereas in our case, if you're not calling your function, there's still a pod running there somewhere. So it's still consuming a bit of RAM, even if it's not consuming any CPU or network. And so that, if you were a mega provider like Amazon, that would be a problem because you're going to have 1 billion customers and they're going to have 10 billion functions. And you want to worry about how much it's going to cost you. But for Kubernetes, that's not really a problem, honestly. You can already create, what is it, like 100 times as many pods as you have physical hosts, about. So if you're going to run 10-ish machines in a pretty modest Kubernetes cluster, you're already at 1,000 functions that you can run. And no one has 1,000 functions they're going to run. You've got maybe 20, if that. So we're not trying to optimize some of those strange cases. We're trying to be very simple and very normal. And then we will benefit from the work that Kubernetes works on. As Kubernetes works to make the pod scaling story better, works to optimize for the idle case, we'll benefit for that for free by being very normal. So that's kind of our strategy with Kubelets. And we'll see how that works out. But that's very simple, very minimal. It's for that 10-line, 20-line case. Don't write your whole program in this. Build a real Docker image, do it properly if you've got 1,000 lines of code. But for 10 lines, this is where this comes in. And I really like the fact that you can do it with kubectl, because when I am messing with my declarative config tools, which is a whole other talk, I can lay out that I've got my code that creates my Jenkins job, it creates my resources that are required, the RBAC rules, all the various other stuff I need to configure my job. And then just in amongst all of the other of them, I also have the webhook, the handler. They're all just created there in the same way, mixed in with the same other declarative resources, which I think is very cool. So that's the idea. That's the talk. So here's why we think this is really interesting, because suddenly the level of commodity, the level of everyone can just assume this, is getting right up to the application. And with things like function as a service, we're trying to get inside the application. We're really trying to get, and I think as an industry, we're so close to getting right up to that point where you know how all the examples used to start with your code goes here? That's kind of where we are now, right? You just give us that code and all the rest just happens. It's boring, it's just there, it's normal. We don't talk about it anymore. And that's super exciting, and I really want to see what we build with this and what we get to sort of next. What are the next problems going to be? So there we are. Thank you very much. Cubelets, it's a youngish project, very interested in ideas, very interested in discussion. If you want to use it, try it out. Very interested in receiving contributions. And I'm around today and tomorrow, and I'm from Sydney generally, so very happy to talk about this at any time. You try and stop me. Okay, thank you.